I'm Mark Maslin, and I'm a professor of climatology at the Geography Department at University College London. In this lecture, what I want to do is to try to introduce you to the fundamental science of climate change and look at the impacts it's going to have on our global society in this century, and then discuss some of the solutions that we can do to try and actually solve climate change. It may sound strange to give a lecture on climate change when we're all under lockdown and worried about the coronavirus. But what's really interesting is some of the actual responses to this pandemic are really useful and instructive because they give us ways of thinking about how we can deal with the much larger problem of climate change in the future. So, the lecture is called Climate Change in the Time of Corona. So climate change is a really old science. We have had the understanding of the greenhouse effect from the 1850s. So take Eunice Foote. She was an American scientist and feminist, and she showed by putting outside two glass cylinders, one full of CO2, one full of air, that the one with CO2 warmed up quicker, got hotter, and stayed warmer longer than the one with pure air. And it was then, a few years later, that John Tyndall actually, at the Royal Institution, measured the exact heat absorption of many gases, including CO2, showing us climate change for the first time. He was also the one that recognized that water vapor was the most important greenhouse gas in the atmosphere. So what is climate change? So if we think about the sun's energy comes in short wave radiation. So most of it is in the light spectrum, and it basically hits the Earth's atmosphere. Now, about a third of it reflects straight back into space, or white clouds or white ice and ice sheets, and we lose it straight into space. But 2/3 of it passes through the atmosphere and hits the Earth. So if you can just imagine for a moment not being in lockdown, not having to go back to school, and you're lying on holiday in the tropics in the sunshine. The sun's energy, which is light, falls on your skin, it gets hot, and then you radiate that heat back. That is exactly what happens to the Earth. And so that heat is radiated back from the oceans and from the land into the atmosphere. And this is where the greenhouse gases get involved, because the greenhouse gases trap a bit of this heat, hold on for it for a little while, and then release it back into the atmosphere, warming the atmosphere and the Earth. So the most important greenhouse gases, as Tyndall showed, was of course water vapor, followed by carbon dioxide, methane, nitrous oxides, and man-made chemicals such as CFCs. Now, if you stripped out all of those greenhouse gases out of the atmosphere, the temperature of the Earth would drop by minus 35 degrees Celsius. So think about that. That would mean an English summer would be about minus 15 degrees Celsius, and an English winter would be somewhere between minus 30 and minus 35 degrees Celsius. So the greenhouse gases keep the Earth habitable and warm enough for life as we know it. But we've already started to warm the atmosphere. We've started to pump CO2 into the atmosphere since the Industrial Revolution. And Guy Callendar in 1938 already recognized this effect. So he took 147 stations, weather stations from around the world, took their temperatures and showed from 1880 to 1938 that the Earth had actually warmed up. And he recognized that this was because of the CO2 effect, because of the amount that we're putting in due to the Industrial Revolution. Now, of course, this has gone up even more. This is the famous Keeling curve, which has been measured since 1956 in Mauna Loa in Hawaii. And as you can see, it has gone up massively since Guy's time. Now, the interesting thing is it's gone up by 45% since the Industrial Revolution, and is at the highest level for at least the last 3 million years. So if we have a look at this on the longer time scale, so this is 800,000 years of an ice core. It shows the up and down of the methane and the CO2 records. You can see the ice ages, you can see the warm periods. And what's interesting is in the ice cores of Antarctica and Greenland, the ice traps some air bubbles around the ice. And these air bubbles are ancient air. So if you can extract it and measure the actual content, you get exactly what the ancient air was. And as you can see, CO2 varies from about 200 parts per million to about 280 parts per million. However, we've now gone beyond 400 parts per million, and so we've increased CO2 about by 45% since the Industrial Revolution, and methane we've increased by a massive 250%. So, are we observing any of these changes in the actual atmosphere? Are we seeing the climate change? So if we have a look at Northern Hemisphere snow cover, you'll see that since the 1960s, this has been dropping markedly. And the interesting thing is that means that things like skiing, snowboarding will actually become harder and more problematic because the mountain snow is starting to shrink and will be there less of the year. If we looked at Arctic sea ice, you can see that, again, since the 1960s, it's been dropping massively, and there are some predictions that sometime this century, between 2050 and 2100, we may have an Arctic that's completely free of sea ice in the summer. The oceans, the big reservoir heat, have been heating up since the 1970s. And of course, that causes the sea to expand. And we can see that plus all the melting of the glaciers and Greenland and Western Antarctic ice sheet is causing sea level to rise. Sea level has risen by about 24 centimeters in the last 100 years. Now, what about temperature? So this is the temperature for the globe, and it's basically being done by about 5 or 6 different groups. I've shown you 3 here: NASA, the UK Met Office, and NOAA. And as you can see, their records are similar, not exactly the same. And again, in science, we always want to know about the weight of evidence, not just one record. We want lots and lots of records. And as you can see, 2016 was the warmest year on record, and 2019 was the second warmest year on record. We wait to find out whether 2020 will be warmer than either of those, and we'll hold with bated breath to find out at the end of this year what the new record is. But as you can see at the bottom, we have the beautiful warming stripes by Ed Hawkins, and it's a very visual way of looking at climate of any area. So this is for the globe, but you can download for any city around the world and every country in the world free script, which you can then produce your own climate stripes. Because University College London is in London, I put up the London temperatures, and as you can see, they go from the dark blues in 1850 all the way to the hot reds of 2018. Of course, this has now started a whole new set of designer fashions. So, of course, the climate stripes can be used as, oh, a beautiful tie. If you have enough money, you can wrap your new Tesla in the climate stripes to have a double whammy, beautiful electric car with the climate stripes. You can do this with a t-shirt. It's not cool to be warm. And of course, you can also have leggings. And I can go on, but you get the picture. So what about the future? Because as a scientist, what I really want to do is have lots and lots of Earths and basically experiment and change one thing on each one and then compare them. But we only have one Earth. So the way scientists get around that is they build a model of the Earth. And these models are grids of data points on the planet and in the land, in the ocean, and into the atmosphere. And we use the fundamental equations of physics to show how the air and the water and the heat moves around. We have chemistry in there, so we understand the chemistry of the greenhouse gases. And we put it all together and we start to model the climate. And again, the interesting thing is because of the growth of the power of our computers, in 1990, you can see that we could only get a resolution in our climate models of about 500 kilometers squared, which really meant that Europe was joined to Britain in a solid 1 brick. By 2013, we had got to the point whereby we could have 100-kilometer resolution. So you can actually see Ireland and Britain are separated. Now, in the next report, which comes out in 2021, some of the models have got down to 30-kilometer resolution. And this is all because of the huge increase in our computer power. So if we imagine the future, we have different scenarios. We put together scenarios of whether we have any climate policies or whether we're going to have really strict policies, such as the 1.5-degree policy, and therefore we see what happens. Now, the interesting thing is, if we go for no policies, almost a business as usual type scenario, then we're looking at 4 to 5.5 degrees warming by the end of the century. The current policies, and what that means is the things that countries are planning to do as part of their response to climate change, 3.1 to 3.7 degrees. Lots of countries made pledges at the climate change negotiations, especially in Paris in 2015. If they keep those pledges, and they are successful, then perhaps we can keep the world to 2.6 to 3.2 degrees. And there's two other scenarios, because all the climate negotiations have always reiterated that we want to keep the planet to 2 degrees. Now remember, we've already warmed up the planet by about 1.2 degrees already, so that doesn't give us much space. There's an even more strict target, which is aspirational, because really where we want to be is we want to be in the 1.5 degree pathway. We want to keep the planet to only warming to 1.5 degrees. Now, what's that mean for Britain? So many of you may have heard of the summer of 1976, and parents and grandparents always go on about how hot 1976 was, had to have standpipes in the middle of the street because there wasn't enough water. And if we look, it was a heat wave. It was a major heat wave, and it's very warm in the British Isles and in Northern Europe. But if we look at 2018, we see that that summer, both in Britain and definitely in Europe, was much warmer than the summer of 1976. And if we then zoom out and look at the globe, because we're geographers, so we're going to put it all in context, you see that 1976 was a heat wave in a little bit of Siberia and in Northern Europe and Britain. But if you have a look at summer of 2018, the whole world was in a heat wave. Very big difference. So summers in the UK will be like those of 1976, 2003, 2017, and 2018. They will be the new normal. And by the way, the picture, as a geographer, I found out that the only desert in the whole of the United Kingdom is Dungeness. So there you are. You can use that for your lockdown pub quiz or Trivial Pursuit if you ever need it. So 2003 was the worst heat wave up to now to hit Europe. And this is London temperatures, and then nighttime temperatures. The reason for nighttime temperatures is because that's when the elderly and the most vulnerable are asleep and cannot maintain their body temperature, and therefore are vulnerable, and many pass away. But look at the geography. If you happen to be in Islington or Hackney or Tower Hamlets, you're going to have a much hotter temperature at night because of the urban heat island than if you were over in Richmond upon Thames over in the west of London. And we know from the records that the peak temperatures were in middle of July, in the middle of August, and the temperatures hit 34 degrees. Now that's 100 degrees Fahrenheit. Now the strange thing is that for us in Britain is really hot, but if you talk to friends in Africa, Southeast Asia, or America, they'll turn around and go, that's not particularly hot. For example, my friends in Texas would turn around and go, oh, 100 degrees Fahrenheit, spring. But in the UK, you can see there's also a peak in the number of deaths. And so the flat line is the normal death rate for the summer, and the dark blue is the peaks that occurred in July and in August. So we think there were 70,000 excess deaths in Europe due to this heat wave. And this is the French deaths for the last 20 years. And as you can see, there is higher in the winter, drops into summer, and back up. But the interesting thing is, if we've got COVID-19 in 2012, a huge increase in the excess deaths. But if we compare that with the heat wave of 2003, the heat wave, A, was much higher, but it wasn't as broad. So it's interesting that the number of deaths due to COVID-19 in France and the heat wave of 2003 are comparable, which is worrying because if you think about climate change, we're going to have more and more heat waves into the future. And it puts climate change into the context of the number of deaths we can see possible in the future. So what about these extreme seasons? How common are they going to be? So we take the 1.5 degree pathway. It means that 1 in 4 summers will be as hot as 2018. If we just sneak up to the 2 degree pathway and we get to 2 degrees, every other year will be as warm. By 3 degrees, 9 in 10 years will be as warm as 2018, which in fact means basically every summer will be as warm. But then on top of that, you have to think that there will be heat waves on top of that new baseline. UK will also have warmer and wetter winters. We're already seeing those. You can think about all the extreme flooding events that we've had in recent years in Gloucester, in Hull, in London, and these will become more common. The reason being is the climate is warming up, there's more evaporation, there's more moisture in the air, and it gets dumped in heavier bursts. We also have to worry about flood risk. So this is the flood risk for London for a 1.2 meter high storm surge coming down the North Sea. Now, the interesting thing is the Environment Agency have plans to protect us from a 4 meter rise in sea level. The maximum predicted by the new IPCC report coming out next year is 1.3 meters by the end of this century. So we're well protected. But if it did happen, this is what London would look like. And the reason why London is so protected is because, of course, there's billions and billions and billions of pounds of property in central London that need to be protected. And this is a picture from the infamous ITV docudrama, which they named Flood. Yeah, even you and I could come up with a more exciting title for a TV program. But it is interesting to note that actually this is highly unlikely due to the plans that the government has in place to protect us. But the other interesting thing about our winters is that we'll still get these cold, sharp snaps, which are like the beast from the east that occurred some years ago. This is because the sea ice north of Greenland and also north of Norway has melted due to climate change. And it means the storms from the Arctic and from Siberia can come down and slam into the eastern side of the United Kingdom, causing huge dumps of snow and cold weather. And the interesting thing is these only last about 3 to 4 days, and then all of it melts. And actually, sometimes the melting of the snow and the ice can actually cause more disruption than the snow in the first place. So this is really important because people perceive that it was a cold winter, but it was only 3 or 4 days of snow, whereas the rest of the winter has been relatively warm and actually quite wet. So we're going to have to adapt and rebuild things like the Thames Barrier to make sure it's higher. We'll have to protect the flood defences in the rest of London, and we'll also have to protect our infrastructure, such as our railways, from the higher sea levels and worst storm surges. So let's summarize. What are the effects of climate change around the world? So the most important thing to realize is that first, we're going to get more extreme storms, floods, droughts, and heat waves. You just have to turn on the TV and listen to the news. The wildfires in Australia, the super typhoons hitting Southeast Asia. Extreme climate events are becoming more and more common. We also have to worry about food and water insecurity. We produce enough food to feed 10 billion people. However, we actually have 825 million people who are on the point of starvation, because food is about the ability to pay for food, not the ability to actually grow it. And so we have to actually contend with this, particularly as agricultural production in key areas and key countries will be threatened by climate change. We also have to worry about migration, people having to move because of sea level rise, because of failing crops, and also the potential conflict that this may cause. Now, the UN Paris Agreement aims to avoid the worst risks by cutting CO2 emissions to net zero during the 21st century. But they warn to do this, we'll have to completely transform the energy generation around the world. We'll have to change our industry, we'll have to change our infrastructure, and we'll have to change our personal behaviors. And this is the actual challenge. So if you can see here on the actual red curve, this is where we've actually got to. And it's interesting because people are thinking that COVID and the lockdown will actually cause a big drop in these emissions. Well, the new evidence is that in April, the drop was about 17% in emissions. Now, that was with very little flying around the world and with little or no cars or transport on the roads. However, it also shows that the majority of the carbon emissions are due to our power generation and the energy we use, not the transport system. The other thing is that even with lockdown going into the rest of this year, the estimates are that the total drop this year will be between about 4 and 7%, which makes 2020's emissions the same as going back to 2006. So we haven't actually changed the baseline that much. We also worry because we saw after the financial crash in 2008, there was a dip in global CO2 emissions. But as the global economy picked up again, actually those just sped up and they played catch up. So we're worried that post-COVID, when we're all recovering from the pandemic, then suddenly everything will go into overdrive and we'll produce even more emissions than we had previously. The other problem is that we want to get to net zero by 2050. Now, the problem is that's great if we can do it, but even then, we need to reduce emissions after that. And what scientists forget to tell people is we need negative emissions for the rest of the century. So for 50 years, we not only have to have zero, we actually have to suck CO2 out of the atmosphere to make sure that we can keep the world to 1.5 degrees. As I said, we have all the science, we have all the technology. It's about putting the policies in place to actually do that globally. So to do that, we need win-win solutions. We need out-of-the-box thinking. We need to change the way we do almost everything on the planet. And actually, the interesting thing is that can make it a better world to live in and actually improve the lives of most people on Earth. So what are the things that individuals can do? So the first thing is talk about it, okay? This is the greatest crisis facing humanity, and we seem to be reluctant to talk about it. So talk about it on social media. Nag your friends, nag your parents, talk to everybody about it, okay? Because actually a lot of the solutions are actually really positive. For example, switch to being more vegetarian or vegan, okay? I love the fact that there's this new term, flexitarian. So therefore you can have a little bit of meat just to keep your cravings going as long as you're mainly vegetarian. And the weird thing is that's great for the planet because it's so much less carbon emissions from your food, but also it's so much healthier for you and therefore means that you have a healthier, longer life. We can switch to renewable energy supplies. That's really easy to do and actually costs you probably the same as your current supplier. We all know the mantra, reduce, reuse, recycle more. We know that happiness and our contentment comes from our friends. our families, and actually being able to do things in the community. It's not about how much goods you have. It doesn't matter how many phones you have. It doesn't make you any more happy. Actually, in my life, it just makes me more stressed because it means that there's more things I haven't done. So we can also reduce the amount of cars. Most of us found that during lockdown, don't really need a car for that many things. And if we do, we can use an electric or hybrid one. They are, just to link in with the earlier one, you can always make it look good with warming stripes. Stop flying. If you must, then offset. What you may not know is there's over 100,000 flights every single day before the COVID virus hit. Huge amount of flying, okay? So avoid it if you can. And if you do have to fly, then you can offset, okay? You can offset your emissions at 10 times to make sure that you have covered the emissions that you have caused. And also, you can talk to your parents and talk to your relatives about their pensions. You can divest them from fossil fuels. The great thing is that University College London is divesting all investments from anything to do with fossil fuels. And so hopefully, by the time you get to UCL, you will be in a university that is divested from investments. It's got a huge sustainability program and is actually going carbon neutral as quick as it can. I also urge you, protest and vote. Who, a couple of years ago, would have predicted that a group of teenagers standing outside Parliament would have changed the world? But it has. The school strikes have been incredibly powerful. Teenagers standing up and saying, not in my name, do not do this. You've got to fix this before we become adults. And it's been incredibly powerful, and politicians around the world have listened. So many governments last year actually declared a climate emergency. They're just not sure what to do about it. And also, when you click over into that magic 18, vote. Vote and make sure people know who you're voting for. Vote for climate change action. Governments. So, okay, individuals can make a small contribution, but we know from the COVID-19 that actually it's governments that control our health and safety. So therefore, they can do the same for climate change. They just have to switch their mindset. So they can support renewable energies. They can tax fossil fuels. They can cut fossil fuel subsidies. Just think of the trillions of dollars that they could save every year for not supporting fossil fuels. And interestingly, hey, random suggestion, they could actually put the money into better health services. Support electric cars and public transport. Support building of carbon neutral buildings and retrofitting all old buildings. Reforest and rewild. To suck all that CO2 out of the atmosphere that we need at the end of the century, then we need about 1 trillion trees planted on Earth. It's also important that we rewild, and we have to make sure that there is a clear boundary between the wildlife and ourselves. One of the problems with the current pandemic is the virus jumped from wild animals into humans, and therefore we had no natural immunity, and why they have become so problematic. So again, having that boundary between biodiversity and our wildlife and our own society is important to maintain for the best of both worlds. We need to promote low emission farming and diets, and of course they should support and expand emission trading schemes to get that CO2 down as quick as possible. And the green economy. People always forget about this because it's so dispersed, you can't point a finger at it and go, look, there's an oil tanker, that's the oil industry. The green economy is worth about $10 trillion per year, according to our research at UCL. Now, to give you some context, the United Kingdom's GDP is about 1.5 trillion. So the green economy is 4 times larger than the UK economy. And guess what? The UK is the 5th largest economy in the world. The UK green economy sales were about 328 billion last year and employed 2 million people, and that's growing really fast. So the battle against climate change will be won and lost by the next generation, you. And so therefore, it is your choices, your stamina, your challenge to actually save the planet from the things we've done. If you're interested in the longer term impacts of humans and how each society has changed the planet and why we've got to this major crisis of today, then please check out my latest book with my colleague Simon Lewis, The Human Planet, How We Created the Anthropocene. And hopefully you've got lots of questions and we'll be able to answer your questions in the future. And I thank you for listening. And I really hope you decide that if you want to come to save our planet, then you'll think about UCL and learning all the ways that we can do it, all the great solutions. And I hope to see you this autumn. Thank you.